Lucid is a Haskell library for generating HTML. The HTML values are constructed in the appropriately named HTML monad, whose type parameter will almost always be the unit type. You can think of the HTML monad as a kind of specialized writer monad. Lucid is not tied to any particular Haskell web framework. The way it works is that once you have your HTML value, you can render it to byte string using this function, and then you can serve the byte string in whatever way you wish. Like in this example, I have a simple way application which serves the generated byte string and also serves an auxiliary CSS file. And then I run the application, the way application using Word. So let's generate some actual HTML. By the way, I'm going to run the server continuously using GHCID. So in order to react to changes in the code. Also, of course, currently we are rendering an empty page. Okay. So the simplest thing we can do is to simply put here a string literal, and it should render in the page, and it does. If we see the type of this literal, it has type HTML. And how does it work? Well, it works because we have overloaded the strings on, and the HTML type has an instance of the isString type class. If we disable the overloaded strings extension, it will cease to compile because, of course, this will be a mere string. But the official documentation always says to have overloaded strings and extend the default rules on. Okay. So now, suppose I had some text lying around like this, and I wanted to insert it into an HTML value. Like, I can simply put some text like this because, of course, this is a text and this is HTML and the types don't match. What I can do is to use the toHTML function, which this function is a method of a toHTML type class which has instances for a lot of types, and in particular to an instance for text. So now it should render bar as well. And notice that the text is escaped. So if I do something like this, like it won't like insert like true HTML elements. It will escape them. Okay, suppose I wanted to wrap this piece of text in some HTML element like a paragraph. I could do it like this. In Lucid, both elements and attributes are always suffixed by an underscore to help avoid collisions with existing functions. Because HTML, the HTML type is a monad, we can do monadically sequence like several of these elements. And it has the effect of simply concatenating the resulting HTML. In fact, this type is also an instance of monoid, so we can do things like this. Okay. What if we want to specify attributes? What we can do is instead, before supplying the inner contents, we specify a list of attributes like this. from ID, from class, okay. And as always, suffix it by underscores. By the way, you may ask yourself, what happens if we add two separate class attributes? What will happen? Will these take precedence, or will they be concatenated? So let's check. They are concatenated. And this is a good thing. This helps with compositionality because uh, in some advanced cases, you might be given some bunch of attributes that you may want to add to your own HTML from outside, and then you can add your own classes without fear that they will uh, override the classes that you have been given from outside, so to speak. So this behavior is useful. Let's now take a closer look at the HTML type. In reality, this type is a type synonym. A type synonym for the following. So it's a monad transformer over identity, as we can see here in the documentation. And the monad transformer has the usual instances that transformers tend to have. In particular, it has a monad IO instance. This means that if we wanted, we could do something like this and allow IO effects while we are creating the HTML. This requires some changes in how the HTML is rendered, but they are easy enough. Uh, So instead of render BS, we use render BST, which uh, brings us back to the base monad after having rendered the HTML to byte string. So we can go off here, edit this, and use. And everything should work more or less the same for now. Notice that we didn't have to change anything here. So everything's the same. So we can try to let's introduce like a lift IO here. For example, let's read the contents of the file. And let's render them with to HTML because byte string also has a to HTML instance. So let's go here. Well, we have here the poorly formatted contents of the README file. I don't expect that in practice you will use a lot of effectful HtmlT values. Like you won't usually perform IO while rendering the HTML, but in any case, it's good to know that the transformer exists because it appears in a lot of type signatures in the haddocks, in the lucid haddock. So it's good to know about it. Speaking of haddocks and of type signatures, if we go to the type signature of the paragraph element, we see that the paragraph element and many other elements uh, have a kind of confusing signature, which says that the paragraph element is a function where the result type and the argument type are related through a multi-parameter type class. And if we open the definition of a type class, it's not very enlightening. There is a type functional dependency that says that the type of the result uh, uniquely identifies the type of the possible arguments, and then there are like three three different instances, possible instances. So which aren't very clear, to be honest. So why are they needed? Okay. Uh, the problem is that in Lucid, the elements like can do very different things. Like for example, here this element is is working as a function of one parameter, the inner contents, which returns HTML, like this thing. Uh, and this corresponds to this instance here. However, elements can also have attributes. And here the paragraph element is working, uh, is a function really of two parameters. Not only it takes the inner contents, but it also takes the, um, the attribute list before that. And that means this means that in that case, this is the instance that it's in effect. It's kind of confusing because we have like this type equality constraint, but it really means that the input type is a list of attributes and the result is a function from HTML to HTML, like this. And then there are the attributes themselves. In that case, the instance that takes effect is this one. So here the output type is a list of attributes, and the input type is a textual value of the attribute. So if we can check here and here. So this is why these instances are needed. And it should be mentioned that, for example, the title element can be an element, but it also can be like an attribute. Okay. So in this case, uh, it's a function from HTML to HTML, but here it's working as a function from text to attributes. One last thing that I wanted to mention is that Lucid plays quite well with Tailwind, the popular CSS framework. In fact, I have here a Tailwind configuration, and I have in the background the Tailwind compiler continuously scanning my Haskell file, looking for Tailwind classes, and generating an output CSS file, which means that I could link that file from my HTML and write some Tailwind classes, and they will take effect. So let's do this. Let's do that. Trying to write the link. Then the href pointing to the put CSS file. And remember that I serve that file in this line of my way application. And now we are going to delete these classes, add a body, a div as well, and I'm going to write some Tailwind classes like with auto and what else? Margin auto with half and background, something like this. And they should be okay. So the Tailwind classes have taken effect. And this is basically all I wanted to say about Lucid. Bye.